So let's talk here about what a logarithm is. So a logarithm is an operation like multiplying or adding. Those are operations. We do them to numbers, right? Something we apply to the number. So a logarithm is an operation, and it is the inverse of an exponential operation, right? So logarithms and exponentials cancel each other out. Sometimes I like to say like a logarithm is a method of counting by powers. Okay, so if you think about powers, like powers of 3, 3 to the 0th is 1, 3 to the 1st is 3, 3 squared is 9, 3 cubed, 27. You notice these numbers are starting to get bigger. 3 to the 4th, 81. 3 to the 5th is 243. And we can make this list all day, continuing to add numbers that will become exponentially larger as we increase that exponent. And something that's going to be critical to our understanding of logarithms, especially once we start solving equations with logarithms, is to recognize some of those special numbers, powers of 3, powers of 2, powers of 5, powers of 7, because they're going to show up. And if you recognize that 49 is actually 7 squared, you're going to make a connection that's going to help you solve the problem. So let's talk about what this logarithm is, though. We have a logarithm with a base, and we apply that logarithm to an argument. Okay, so what is in the parentheses is the argument. That's the vocabulary word there. So just as when we were dealing with exponentials, b is the base. B must be positive. When we say something's greater than 0, we're implying it must be positive. And just like with an exponential, the base cannot equal 1. Okay? So the exact, phrase that we can use to define a logarithm is that a logarithm is the power to which we raise the base to get the argument. Okay, to get x. And in this situation, x is my argument. So we're going to be thinking about, looking up here at the top, we're going to be thinking, well, what power can I put here that will make it equal that? And that's what a logarithm is. So as we proceed, we want to know or feel comfortable converting logarithmic to exponential form. And so you'll notice over here on the left, I have log base b of a equals c. This is a logarithm of base b, argument a, and it equals some output c. Okay? Remember, logarithm is the inverse of an exponential function. So I can convert that to b to the c equals a. So the base raised to that output equals my argument. All right, so we're going to get some practice in this video manipulating logarithms so that we can expand them, condense them, shift them around, and feel comfortable with them so that we can use them later. All right, so the book defines it. They just use slightly different variables. They use x and y. I find that a lot of the problems already have x and y, and it can be confusing when we are converting, but whatever definition works for you. Variables are variables. They can be whatever you want them to be. So here we can define this as log base b of x. It is y such that b to the y equals x, as long as that argument is positive and b, the base, is a positive constant not equal to 1. And so this is just the same conversion formula. And if I wanted, I could write this definition with all symbols. I could say log base heart of smiley face equals star. And if I wanted to convert that, that would become heart raised to the star power equals smiley face. So we're just going to be moving positions, okay? And this is, I use this with the symbols instead of the variables just to illustrate we're just taking things and switching them around. And the variable doesn't matter as long as you know where everything moves. Okay, so let's talk for a second here about some special logarithms. So when there is no base written, no base, we're going to assume it is a common log, and a common log is base 10. So if you see some problem and it says log of x, and you're like, well, where's the base? That means it's a common log. So we're going to write log base 10 of x. And then natural log. Natural log is a special base as well. Natural log is base e. E is Euler's number. It's approximately 2.718. There's an E button on your calculator. There are actually two. We write ln with a cursive ln or a capital ln. We don't like to write lowercase because it starts to look like a 1n in that situation. So if you see ln x or ln x, that means log base e of x. And if you go and look on the left side of your calculator, on your TI calculator, beside the 7 and the 4 buttons, you're going to see one button that says log. Above it, you'll see a 10 to the x, and you'll see also a button right below it that says ln, and that has an e to the x above it. So the calculator only has a log and an ln button, so it can only directly type a base 10 or a base e log. But we know that logs can exist for any base as long as it's a positive number not equal to 1. So when we need to deal with that, we talk about our change of base formula. So the change of base formula says that if I have a log, if we have log base b of some argument, I'll call it capital A, I can rewrite that as natural log of A over natural log of B, or common log of A over common log of B. Okay, so it's log of the argument over log of the base, and you just need to be consistent using either your common log for both or your natural log for both. So for example, if I asked you to type log base 2 of 10 and give me a value in your calculator, you would do ln 10 divided by ln 2. And typing that into your calculator, the value I get is approximately 3.32192,809. And I'll get the exact same value if I were to type common log over common log. Okay, so we can type any base, it's just it can be a little more complex. And we have two other properties here of logarithms that we're going to talk about. So the first property here, we have the same base and the same argument. And whenever the base and the argument are the same, the logarithm is going to equal 1. And some examples of this, if I have log base 2 of 2, that would equal 1. Or log base 3 of 3 would equal 1. Common log of 10 would equal 1. Natural log of e would equal 1, because natural log is base e. Okay, so when the base and the argument match, the logarithm is going to simplify to 1. And my other property says, regardless of the base can be any number. If I take the logarithm of 1, my output is going to equal 0. So regardless of the base, if the logarithm argument is 1, your output will equal 0. So log base 2 of 1 is 0. Log base pi of 1 is 0. Common log of 1 is 0. Natural log of 1 is 0. And so knowing these two properties, this is going to help us simplify as we move through some of these problems.